yeah, factoring sums and differences of cubes. When I say cubes, I mean the terms are to the power of 3. They're cubed. Okay? So, this is the general rule, but I ended up breaking it down in case this was a little bit confusing. So if you have a cubed plus b cubed, simply is the sum of the bases times the first term squared, or the first base squared, minus the first term times the second term plus the second term squared. This is always a plus. No matter what happens, this is always a plus. So whether you have a cubed plus b cubed or a cubed minus b cubed, this is always positive. Always positive. If it's a cubed plus b cubed, then the first parenthesis is the sum of the two bases. Okay? This sign is always the opposite of the sign. So since this is a plus, this is a minus. So, let's make a quick example. X cubed minus or plus 64. Okay? X cubed plus 64. We need to look for perfect cubed. That means what base to the power 3 equals to 64. We also call it the cubic root. So if you have a calculator, you can plug in the cubic root of 64. Okay? Now the answer should be 4, because 4 times 4 is 16. 16 times 4 is a 64. So, to put it back in the form of a cubed plus b cubed, x is already cubed, we don't need to do anything here, plus 4 cubed. This is awesome. Let's apply the rule. So, my first parenthesis is simply the sum of the two bases. Why? Because I'm adding. So this has always to be the same sign. So you get x plus 4. Now my second parenthesis should have my first base squared. My first base squared goes over here. My second base squared goes over here. No matter what, this is always a plus. Always a plus. This sign is the opposite of my sign, my original sign. It's the opposite of the original sign. So since this is a plus, my new sign is a negative or a minus. Then you multiply your first base times your second base. AB, right? So your first base times your second base, or x, no powers. Again, we made it in the form of x cubed plus 4 cubed in the form of a cubed plus b cubed. Your first parentheses is simply my two terms added together without the power, the bases, just the two bases. Your second parenthesis is you square the first, square the last. Always, always put a plus. The sign is the opposite of the original. You multiply your two bases. Let's try with the negative sign or with the difference of cubes. This is the sum of cubes because we're adding sum of cubes. Let's try the difference because we're subtracting. This is the differences of cubes. Okay. It will follow the same exact rules and standards. So, let's try this time x cubed minus 64. Just notice how the two problems look alike. The only difference is this is the sum and this is the difference. Again, the first step is the same. Have x cubed minus 4 cubed. I just put in the form of a cubed minus b cubed. Now let's factor out. Since we're doing the difference of cubes, then my first parenthesis will have the difference of the bases. So, have x minus 4. This is a minus, so this has to be a minus 2. Second parenthesis, you take the first base squared, your second base squared. No matter what, here's always, always put the plus. This sign, again, is the opposite. So if that was a minus, we have a plus. Then you multiply your two bases. Or let's look at some questions from your worksheets. 8a cubed plus 125. Okay. So, my first step is to make sure that you put it in the form a cubed. In this case, we're adding, so it'll be a cubed plus b cubed. Okay. Now, is the 8 a perfect cube? Think about it. What base to the power 3 equals 8? In other words, what is the cubic root of 8? Should be 2. 2 times 2 is 4, times 2 is 8. So, get 2a all cubed plus, what is the cubic root of 125? Simply 5. 5 times 5 times 5 is 125. So now I have it in the form of a cubed plus b cubed. Let's apply the rule. So we're doing sum of cubes. Therefore, it's going to be my first base plus, remember the signs are the same, the second base times my first base squared. Please use parentheses to avoid any confusion. The second base squared. Remember, this is always a plus no matter what. Always a plus no matter what. This sign is always the opposite. This is the stubborn one. Always says, I'm different. I'm the stubborn sign. Okay? Stubborn zone. This sign is very peaceful, just follows the lead. Okay, good. Now, first term times the second term, or the second base. So my first base is 2a, my second base is 5, so it's 10a. Now, let's simplify it more. Yeah. 2a plus 5 times 4a squared. It's 2 times 2, or 2 squared is a 4, and a squared is a squared. I'm still stubborn and different. This sign always follows the lead. 5 times 5 is 25. Okay, another example. It's 125 minus x cubed. Again, we need to put it in the form of a cubed minus b cubed. So we did that in the previous example, and we said the cubic root of 125 is 5, because 5 times 5 is 25 times 5 is 125. So we have 5 cubed minus x cubed. Okay, apply my rule. I'll draw my 2 parentheses. It's going to be my first base. We're doing difference, so minus the second base. This sign is always stubborn, so if this is a negative, this is a plus. Always stubborn, always different. This poor sign follows the lead. Same sign. Now, my second parenthesis, we square the first term. We square the second term. And then we multiply both of my bases. Simplify it more. We get 5 minus x times 25 plus 5x minus x